Okay, we've talked about dew point and dew point at the surface, which is dew or frost or frozen dew. And we've talked about dew point just near the surface and fog. And now we're going to talk about dew point at altitude and clouds. So we classify clouds in 4 ways. Well, we classify clouds as 4 different types. One is high cloud, middle altitude clouds, low altitude clouds, and clouds that grow vertically, or vertical clouds. Let's get into it a bit. Sorry about that. In regards to this diagram, I think this will help you out. On top, of course, are high clouds, the cirrus clouds. And in the middle are middle clouds or alto clouds. And in the bottom are low clouds or stratus clouds. And along the side here is cumulus clouds or clouds with vertical development. We're going to talk about all the specifics of these clouds so that you can read them a little bit better. And you have a cloud chart in the back of your textbook if you have a paper textbook. If you don't, I'm sure you have one in the online that you can reference, a cloud chart. Let's start with the high clouds and go down to the low, and then we'll do the vertical. The high clouds are called cirrus clouds. It's from the Latin cirrus, for curl, especially a curl on the top of your head. They are on the top of the atmosphere, so they are called cirrus clouds because they curl up with the winds that are near the stratosphere. So in regards to that, there are basically 3 types of cirrus clouds. What you're seeing here are pure cirrus. They are known also as mare's tails because they're so flighty and they are so thin up there. There are also Cirrostratus, we'll get to that in a second, and Cirrocumulus clouds. But as you know, they're all, start with the word cirrus, they're all high up. The Cirrostratus clouds are more of a layer of clouds. They're thin and they form a layer that can often reflect out the sun as a halo. That halo is actually a sign of advancing storms in the mid-latitude regions. Mid-latitudes being anything from the tropic of Capricorn, the tropic of Cancer, up to about the 50s. So about the 30s to the 50s in the mid-latitudes. This in particular is the halo before Hurricane Isabel. These halos are seen about 2 to 3 days before a major event. So those are Cirrostratus clouds. They form a thin layer very, very high up. There's also Cirrocumulus clouds. You'll learn that cumulus stands for accumulation. So these are kind of puffy clouds that are very high up. They tend to look like the scales on a fish that come up when the fish comes out of the water. They kind of elevate themselves. So these are cirrocumulus clouds, very, very high up. And then we can talk about middle clouds, alto clouds. A mnemonic for that is to remember that alto singers have a middle of the road voice. They're not sopranos. They're not very low. They're in the middle. I'm an alto. So those alto clouds are in the middle of the atmosphere. They are generally, they have a grayish tone to them. They can be grayish with a little bit more blue. They can be grayish with a little bit more white, but you'll see the gray there. They signal that precipitation is coming in about 1 to 2 days. So first you have the cirrus clouds, 3 days out, then the clouds will drop to about 2 days out, and finally we'll get to the lower clouds in a few minutes. Those alto stratus clouds, again, they're middle clouds forming a layer. That layer can look not as a halo, but as a watery sun. A grayish tone to them, that they sort of mask the sun to them. They're signaling that the precipitation is coming in about 2 days. You can also have the alto cumulus clouds, which are again are the puffier clouds. And if you compare them to cirrocumulus clouds, These alto cumulus clouds are a little bit darker, all right, a little bit puffier, a little bit more vertical development to them. You'll often see them on summer mornings, and they are predicting that by the afternoon you might have some thunderstorm clouds, some true cumulus clouds. We'll get to that in a second. And then those alto cumulus clouds are right at the right altitude at sunrise and sunset to scatter the red ultraviolet waves and really show brilliant sunsets and sunrises. The alto cumulus clouds are responsible for the old wives' tale that has a lot of scientific basis to it, that red skies at night, sailors delight, red skies in the morning, sailors take warning. That is very much a well-known dictum in the northern hemisphere, and it is because of the scattering of red ultraviolet light in dense atmospheres that include these clouds. So those are alto cumulus. Now, the lower clouds are called stratus clouds, and they're called that for another reason. In Latin, Latin has stratus for straw, and if you think about it, a farmer would scatter straw in his barn, or even he might scatter straw in his fields as a bedding, as a cover for the fields or for the barn. And these clouds are like a low covering for the atmosphere. Stratus clouds are often flat like a sheet, or they can look like a blanket like this. These stratus clouds, some of them, this is a true stratus, known as a fog, a low layer, and there are also stratus cumulus and nimbostratus clouds. So we'll get into that, but we've moved from fogs into calling them stratus instead. You could have cooling stratus or evaporative stratus. With the stratocumulus, again, these are puffier clouds. If you compared them to alto cumulus, they would be even darker than alto cumulus. You can see the gray, the dark gray coming in here, because they are clouds that are more dense, and they are riding lower, and they're filled with precipitation that is building. So they have the same sunset timing as the alto cumulus, but they're puffier and they're larger than the alto cumulus, and the alto cumulus was larger than the cirrocumulus. So you can see where we're going to here. The nimbostratus clouds are the very interesting clouds that seem to come in with sheets of precipitation. You can see that sheeting of precipitation right here, and they move very quickly on the wind, and they move in shapes in the wind. Nimbostratus, nimbo as in nimble as in quick. These will form rain and snow clouds. They are the clouds. Remember, the cirrus came in 3 days before, the alto comes in 2 days before, the stratus comes in that day with the precipitation. Fourth type of cloud, clouds with vertical development, are cumulus clouds. So while you can notice clouds coming in generally over the course of a few days, cumulus clouds can bring in thunderstorms within a day. They start as cumulus clouds in the morning with a lot of blue around them, and then they'll build during the day, and we'll look into how they build. But the mnemonic to remember cumulus is to remember accumulation, right? It means a heaping on of things. You've got an accumulation of work this week, a heaping on of work. So these clouds look like they have little heaps to them. They're cumulus clouds. Like I said, they will start during the morning with a lot of blue. The blue is the downdraft. Let me show that to you a bit. These clouds form during the day from warming surfaces that conduct out to form a little parcel. that then gets convected up because warm air rises. This little parcel warms and this is where we're going to start to get into the idea that warm air rises and cools and expands. So this is the start of getting into that. This warm air will rise, it'll cool and condense and expand out, and around it, cool air will drop in a downdraft. So these are known as fair weather cumulus, and they could stay fair weather cumulus, or they could build to what's called cumulus congestus. As in congestion, those downdrafts start to disappear and the clouds begin to get congested across the sky without the blue downdrafts in between them. So these are cumulus congestus, and what I will say is this, that not all cumulus clouds grow to be thunderstorms, but all thunderstorms start as cumulus clouds. So these could become thunderstorms, and what I would say is that the cumulus congested clouds, obviously you see the congestion down here, but they have really sharply defined upper limits. Okay, that's cumulus congestus. And when you start to see the anvil at the top, it's a different kind of cloud. It is a cumulonimbus. It's moving rapidly, nimbly in a vertical direction, and it forms the anvil as it meets the stratosphere. Remember, the stratosphere is warmer than the troposphere, and as a result, those rising parcels in the cumulonimbus cloud cannot rise any further because they are no longer warmer than the air around them. The stratosphere up here is warmer than the troposphere. It puts a lid on clouds at about 60,000 feet up. And here is the nimbus section, the precipitation section here that forms. It's a great photograph there. There's the rain, and there is the drying section of the cloud. We'll get into that soon. So those are cumulonimbus. That's a great one. I just had to throw that one in. It's a great cloud. And a very, very nasty cloud. When we look at, just review, high, middle, and low clouds, cirrus, alto, and stratus, we are looking at the height of their bases that differs by latitude. And what I wanted to show to you is that the tropical latitudes between the equator and about 25 degrees latitude are tropical. Mid-latitude region, 25 to about 45, 50 degrees latitude. Polar region, anything from 55 to about 90 degrees up to the North Pole. And what you find is that these clouds that are in the tropical region have their bases that are higher because they have so much warm air that they are convecting up. So look at these, okay? Let's start with the low clouds in the tropical region. They go from 0 to 2,000 millimeters up. And that's standard across the way for the stratus clouds. What you start to see in the altos is the differential coming in with all of that warm air that is convecting upwards. That the alto clouds in the tropical region, 8,000 meters. Alto clouds in the polar region, 4,000 meters instead. Really starts to come into play in the higher areas. 18,000 for the cirrus clouds in the tropical region, 8,000 for the cirrus clouds in the polar region. Much like the assignment that I gave to you, the stratosphere is going to be higher in the tropical regions. So much warm air in the atmosphere. The stratosphere is going to be lower in the polar regions. Not as much warm air in those areas to lift up the stratosphere. I think, one last one. We create our own clouds artificially, and it's a major source of pollution in the upper atmosphere. We create our own clouds by contrails from jet engines that are exhausting out